In this video, I'm going to be giving an introduction to combinatorics. So let's get started. So obviously we've seen permutations, and in permutations, let's say we want to choose for the presidential election. There's two candidates, and how many ways we can choose the president and a vice president from 6 candidates. Let's say with 6 candidates. So 2 candidates. We have 6 for the first choice and 5 for the second. So our answer is 30. And this is a classic permutation problem. This can also be written as P in the permutation notation. Can be written as 6, 2. That's how we can write this. Which is also just 6 times 5. So when it comes to combinatorics and permutations, here's the difference. In permutations, let's say we want to arrange, or let's just give an example. We're counting some letters here, and let's say we're counting words, right? How many how many words can be formed of A, B, C, the letters A, B, and C, using distinct letters? So we cannot repeat a letter at all. So we'd obviously just keep going on. So we obviously start with ABC. That's our first word. We can maybe do a BCA. In permutations, these are two different types of. These are two different counts. So we obviously have 2. In combinatorics, it's different. In combinatorics, order doesn't matter. So order does not matter in combinatorics. In combinatorics, these two are the same. It's the same exact thing. But in permutations, they're different. So this would be combinatorics and this would be permutations. And that's just one way of seeing it. And there's 2 different types of problems as well. So I'm going to give an example of combinatorics here quickly. So when it comes to combinatorics, let's say you wanted to choose a 3-person committee out of 6 people. So a 3-person committee out of 6 people would be, well, since let's just get started with the 3 people. We have 6 for the first 6 choices, 5 and 4, 3 people. But then notice how order doesn't matter. So remember, person A, B, and C is just the same as choosing person B, then C, then A. So since we have 3, we need to divide, because this is just counting everything 3 factorial times, and then we can cancel. And obviously this is just 6 times 5 is just 30. But since we've canceled it, obviously we can just 2 times 5 is 10. 10 times 2 is 20. So the answer is 20. Now that we know the basics of combinatorics, we know that there should be another way to write this in terms of combinatorics. And you're right, there is a way. So when we have such a problem like this, when we're choosing a number out of something, we call this, we use the combinatorics notation, which in this case is just 6 choose 3. Can be written like this. So 6 choose 3 can be computed in many different ways. So if I have 6 choose 3, this is equal to 6 times 5 times 4 divided by 3 times 2 times 1, or 3 factorial. And we can compute this. Now, given this, we need an easier way to compute these. So let's say I have k choose n. Well, k choose n, the denominator is going to be n factorial. And at the top, we're going to have k. We're going to multiply it by... Now, when we have such a thing here, especially when we have k choose n factorial is denominator, and in the numerator, as we saw with 6 choose 3, 6 times 5 times 4, 3 times 2 times 1. The bottom is just 3 factorial. 3i, 3 factorial. The bottom is 3 factorial. And the top is, well, first we have k times k minus 1 and it just goes on and on and on. So that's how we would compute such a thing. Now let's give another example. How many ways can we choose 3 people from a group of 8? And this, obviously, it's in the name 8 choose 3 is just our answer. And when we have problems in which we're choosing and forming committees, and forming a 3-person committee out of a group of 8 people, it's just 8 choose 3. We're choosing 3 people out of a group of 8. And then we can just compute this, which is just 8 times 7 times 6 divided by 3 factorial. 3 and the 2 canceled the 6, and we just have 56 as our answer. So obviously we have a large number of these. We want to be able to compute them fast, and we want to be able to compute them efficiently. So the way we do this is we find things that are equivalent to the combinatorics. So let's say we have something that, like, let's say we have 11 choose 8. Now we can just write this out, but 11 choose 8, we have a special rule for this. Now in this rule, 11 choose 8 is equal to 11 choose 3. And here's why. The rule states that if we take the difference, or I'm going to actually write this in a more generalized way. If we have n choose k, the equivalent of n choose k is equal to n choose n minus k, which is just n over n minus k factorial. So n choose k can be written as n choose n minus k. That's how this can be written. And we can see that with over here in our problem. 11 choose 8 can be written as 11 choose 3. In this case, n is 11, k is 8. 11 minus 8 is 3. That goes in the bottom. 11 choose 3 can be easily computed. 3 factorial. And then 11 times 5 is 55. And 55 multiplied by 3 is our last remaining term. And 55 times 3 is 165, which is our answer. Now let's say we have two separate committees. Let's say we want to form a committee, a large committee, in which we have, let's say we have 3 people from the math club at our school, and these are like the best people at math, and we have 6 people from the science club. I'll actually erase all on one side. So 6 science and 3 math. Alright, so, and we want to form a committee in which we have 3 science and we want 2 math. One person's gonna have to be eliminated from the math team, and 3 people have to go from the science team in order to qualify for this STEM team. Alright, so over here, the way we're going to solve this problem is think of this as 2 separate committees. So over here, when we're choosing our science people, we have 6 people to choose from, and this is just 6 choose 3. Right? This is just 6 choose 3. And there's 3 people in the math club. We want to choose 2, so this is just 3 choose 2 for the math. And we can just compute this. So we can't really simplify this because 6 minus 3 is 3, and that's just going to be another 6 choose 3. We can, however, simplify this as 3, and then 3 minus 2 is 1, 3 choose 1. And we have 3 choose 1, we have 6 choose 3. Now, we have 6 choose 3, and we have 3 choose 1. We're going to compute the 6 choose 3 first, so that's just 6, 5, 4, 3, 2, 1. So 3 and 2 cancel the 6. Then we have 20. So this can be rewritten as 20 for the science. We already computed the science. And the math, 3 choose 1 is just 3 divided by 1, which is 3. So we have 20 multiplied by 3. This is the science, and this is the math. 20 multiplied by 3 is 60. There are 60 ways we can choose this. So whenever we have 2 committees, we want to combine them by computing each committee separately and then multiplying the results. So in this case, we had 6 choose 3 multiplied by 3 choose 2, which was our answer in the end, which is also just 60. Now, we're going to go over some rules for combinatorics. First off, n choose 0 is always 1, no matter what, for any value of n. Right? So n choose 0 is always going to be 1. Now, k choose 1 is going to be k. And this is because this is just k over 1, which is just k. Now, another rule you have to remember is k choose k. Now, k choose k is also going to be 1. And we'll look at each of these in a moment. So n choose 0. If we look at n choose 0, 0 factorial is just 1. We can't really prove it to you right now, but n 0 factorial is just 1. K choose 1 is basically choosing 1 item out of k items. So that's just going to be the k. And you can also write this as k and then k over 1 factorial, which is just 1, which is just k. Now, k choose k is choosing every single item out of every single item. So that's just one way to do that, right? So k choose k is going to be 1. We can see this if we do 2 choose 2, which is just 2 times 1 over 2 times 1. And also, we can go in depth because k choose k is again k factorial over k factorial. Now, in terms of factorials, k choose 0 is just k factorial in the numerator, and 0 factorial times a k factorial. That's how we write it in terms of factorials. And in terms of factorials, k choose 1. Well, in k choose 1, there's no point to writing factorials. We just know that's just going to be k over 1 factorial. So that's the easiest way to write k in terms of factorials. That's in terms of factorials. Now that we know all of this about combinatorics, we're going to end the video with some more rules and some more quick simplifications. Now let's say you have a large problem in which you're trying to choose, let's say we have 16 people that we have to choose from. We have to make a 15-person committee. Right? We have to make a 15-person committee of people. So that's 16, choose 15, which is just in the name, you're choosing 15 out of 16 people. So over here, if you remember, we talked about a simplification rule, which was useful in a large counting problem. So over here, we can just do a quick simplification. 16 minus 15 is just 1. 16 choose 1 is 16. And we remember from our rule, k choose 1 for any value of k is always going to be k. And we can apply that rule over here. So that is an overview of combinatorics. Hopefully this video was helpful. And yes, that is the introduction to combinatorics.